First design matrix, very important design matrix we have seen, that is a time to market, and also we have seen the impact of launching your product on time, and if there is any problem by launching your product on time, then you have to pay for the revenue cost. Okay, that we have seen. Second very important design metric that we have seen, that is a non-recurring cost and the unit cost matrix. Okay. And also we have seen in this NRE unit cost, we have seen that how to recover the NRE cost. Okay, that is if you spread your design cost, okay, over number of unit that we have manufactured, okay, then it is possible to find to recover the design cost of your product. Okay, so that is what is shown in the slide. Okay, that is amortizing NRE cost over the units results in an additional $200 per unit. Okay, so you can spread your design cost over over the number of units we have produced. Okay, and in this way we can reduce the cost of the product also. Okay, so here two examples we have seen. That is, if you manufacture 10 units, then there is a $300 that is a per product cost. If you go for 100 units, okay, that is only $120 per product cost. So you can reduce the per product cost by increasing the number of units. So that we have seen. Okay. So up till now this is clear, I think, isn't it? Is it clear? So we go for the next. We go for the next point. That is again there is a problem. So next, in next slide, we'll see the NRE and the unit cost matrix. Okay, so there is a simple example. There is a simple example of NRE and unit cost matrix. Okay, that means how to deal with NRE and unit cost matrix. So there is a simple example. We have to compare some technologies. Okay, by cost. So there are three technologies. Let technology A. Okay, so technology A, the NRE cost is let $2,000. Okay, just pay attention for some time. Okay, this is important because there will be questions on this. Okay, that is mathematical questions on this. Okay. So in this example, we have three technologies: technology A, B, and C. Okay. Now, if technology A, NRE cost, that is the design cost of your embedded product, is $2,000. Okay. Whereas the unit cost is $100. Now, if you use technology B, then your NRE cost is $30,000, and the unit cost is only $30. So if you use technology C, the NRE cost is $1 lakh, while unit cost is only $2. Just see. Now, this is what the example that means. Let you have three technologies available to manufacture your product. Okay. Now my question is, out of these three technologies, which technology we have to select? Which technology we have to select? I have put the question into the chat box. So what is your answer? I have given three technologies: technology A, technology B, and C. That I have to manufacture some number of products or embedded systems. Okay. Now I have three choices: technology A, B, and C. Okay. Now I have a problem that which technology I have to select. Okay, and on which criteria, and what is your criteria, on which.
If we want better quality, then we'll go to technology B. And if we want a number of units, then we'll go to technology A.
Technology A. Okay, so here
If
is
you
a,
want number of units,
okay,
then.
if you want,
If we want number of units, that means if we want more number of units,
okay,
then we will go to technology A. And
okay.
if we want quality of the unit, then we'll go to technology B.
What do you mean by quality? Yeah, just see, the quality of,
Quality
oh,
means we are investing more amount to get the better quality of our technology.
just see, first part is correct, but in the second part, just see, we have only two design metrics here. That is only NRE and unit cost. Right now, there is no issue of the quality. Okay, either you go for technology A or technology B or technology C. The quality of your product will remain the, that is the very good quality. Okay, so first of all, this thing should be clear. The quality of the product is very good. Either use A, B, C, because that is what the requirement of the market. Okay, so quality is not issue here. First of all, the quality you are providing, that is always best. Now you have to think only in terms of NRE cost and the unit cost only. Okay, so if you observe it carefully, now this is what observation. If you observe carefully in technology A, you see the NRE cost. What is NRE cost? The design cost. Okay, that means before manufacturing your product, the design cost is $2,000. Okay, however, the manufacturing cost of each unit is 100. Are you getting? Now you compare the this first technology with the second technology. Now in second technology, that is in technology B, now the design cost is increased. Now what is the design cost? That is NRE cost is 30,000 compared to the 2,000. Okay, so here design cost increases, but the manufacturing cost of that unit is reduced to 30 only. Okay, now next, technology C will require again higher design cost. Okay, that is the NRE cost of $1 lakh. Just see. So from technology A to ABC, so the design cost increases. However, the manufacturing cost decreases. That is 230 and $100. Just see. So now you have to select one of the technology, and the answer is very simple. So if you go through the graphs, just see. The first graph is number of units versus the total cost. Okay. So if you observe the three technologies, technology A, B, and C, just see they have shown it with different texture. So if you see the that is technology A, okay. So technology is shown with the help of squares. So technology, if you observe technology A, so this graph shows that as the number of unit increases, just see, as the number of units increases, the total cost of the product is also increases. What is the total cost? The total cost is equal to NRE cost plus the design cost. Okay, sorry, NRE cost plus the unit cost. Okay, so this parameter goes on means increases. So as your number of units increases, the number of, sorry, the total cost is also increases. So this is not again I say good options. Okay, because total cost increases, so no one will purchase the product which having the higher total cost. Okay. Next is technology B. You just observe technology B is shown as here. That is again as number of units increases. Okay, the total cost also increases, but compared to technology A, the total cost of technology B is lesser. Okay, so I can use this second one because the total cost is less compared to technology A. Now you observe the technology C that is shown by that cross mark. So that is almost flat. That means either you increase the number of units, whether it is 0 or maximum, the total cost remains same. Okay, so that is also one of the way or one of the advantage of technology C. Now in the second graph, they have plotted number of units versus the per product cost. Now just see how to recover the NRE cost. Now I can recover the NRE cost by using this particular graph. So again here you compare the three technologies A, B and C. Now the first technology, that is technology A, you just observe that is a square. So as the number of units increases, okay, the per product cost is also quite decreases, or I can say that that is a flat, okay, from technology A. From technology B, you just observe if there are less number of product or units, the per product cost is higher. But if I increase the number of units, the per product cost goes on decreasing. Okay. Then for C, that is for technology C, okay, it also having the, that is, if the number of units are lesser, then the total cost is also very high. But as you increase the number of units, the cost goes on decreasing. Okay, so I can say that technology B and C having the good advantage if you increase the number of products. Okay, so what is the criteria to select the technology? I cannot select technology A, or I cannot say that technology A is good or B is good or C is good. Okay, so the selection of the technology is directly depends upon, okay, on the number of units that we plan to produce. Okay, how many number of units we have to produce. Okay, so accordingly you can select technology A, B and C. Okay, so that is what the answer. So for this you have to take some example, like let you manufacture the 10 units, 100 units, okay, 1000 units, and let 1 lakh units. Okay, let this is an assignment to you paper. Okay, I have given the three technologies, NRE cost is given and unit cost is given. Now you have to find out the per product cost. Okay, for total cost and per product cost for units, that is 10 units, 100 units, 1000, okay, or 1 lakh. So that there are four different types of units you have to manufacture, and you find out the per product cost and the total cost for each technology. So if you go through this particular calculation, you will come across the conclusion that the best technology choice will depends on the number of units we have planned to produce. Okay, that means the selection is directly dependent on the number of units we will produce. Okay, why this is so? Because as you increase the number of units, the per product cost goes decreasing. Okay, so that is what the conclusion from this particular slide. Okay, so just we have compared three different technologies, and each technology having different NRE cost and the unit cost. Okay, so you have to find out the total cost and the per product cost, okay, for different ranges of your units, and then you come to the conclusion that you cannot say the technology A is better or B is better or C is better. Okay, so maybe the technology A is better, okay, for less number of units. Okay, if you also in the graph, if there is a less number of units, the technology A having a very small product cost, maybe at least up to $120 if you also in the graph. But for the same number of units, the technology B and C having a higher per product cost. If you also in the like 180 and something 220. So that is what the cost for the less number of units for all these three technologies. So if you compare for a less number of units, the technology A will be the better. Okay, but if you compare for a more number of units, okay, so that time technology B or C will be the good choice. Getting? So this is how to select a given technology. So in the exam there might be a questions on this. Okay, is it clear? Everybody? Okay, is it clear? There are 26 students right now. Is there any problem with this? NRE cost, unit cost. Okay, so this is what the mathematical proof to how to recover your NRE cost. Are you getting? So how to recover the NRE cost? Simply by increasing the number of products. Okay, that means if you do the mass production, it is possible to reduce the cost of your unit, and it is possible to recover the design cost also. So that is what the conclusion from this. I think this is clear. Then we go for the next point. Now the next point is again the design matrix. Okay, but the point is very important. That is, let you have designed some embedded systems or some product. Now you have to check the performance of that product. Okay, that is, you have to check the behavior of your product, whether it is behaving properly or not. Okay, so what are those different performance design metrics? Okay, so in every embedded systems, or maybe in every systems, you have to check some design metrics. For example, you people having some performance measure like CGPA or HGPA, so that is what the design metrics. So depending upon the these grades, all the students will be, or the performance of all the students will be compared. Okay, maybe in grade A, B, C, D, likewise, whatever the grades. So likewise, how to compare the performance of your embedded systems? So there are some design metrics. Okay, so very first design metrics called as this one, called as a widely used measure of systems or widely abused. That is nothing but the clock frequency. Okay, so what is the performance parameter we will check in our embedded systems? Now all embedded systems will work on the clock frequency, that is on crystal frequency. Okay, so that is nothing but the clock frequency. So the first criteria, or that is called as a general criteria of checking the performance, is the clock frequency of your embedded system. Okay, so whether you are using a crystal of 4K, sorry, that 4 megahertz, 10 megahertz, or 11 megahertz, or the 12 megahertz. Now, what is the advantage of clocks? What is the advantage of clock? Uh, Whether the clock frequency should be higher or lower. Just give me some answers. Let I have to use some crystal in my embedded systems. I have a choice, that 4 megahertz, 8 megahertz, that 12 megahertz crystals are there. So which crystal I have to select and why? This is what the oral questions. Everybody please, whatever your answer, just put into the chat box. Are you getting the questions? Okay, Saili Putwal has raised hand. Okay, you can unmute yourself and you can talk with me. Unmute yourself, no problem.
Sir, mistake नाही झालं.
Oh, no problem. You can give the answer still. So what is your answer? Kajal Jadhav has just admitted into the lecture. Anybody? Abhishek is there? Abhishek Dhavde, Prashant Zarad, Rohit, or nobody is there. They have just make Zoom meeting on.
As per the requirement of operation,
Okay.
most of all 4 megahertz is selected.
Okay, 4 megahertz. Why 4 megahertz?
Because it is standard to use the microcontroller, and if you use 4 megahertz, then it is sufficient to operate our microcontroller as well.
Okay. Now my very simple questions. Now, what is the relation between the clock frequency and the speed of the system? Okay. So my question is whether the speed of your embedded system is dependent on the clock frequency or not. So this is the question to everyone. Just say this is very simple questions. Okay. And you might get these questions in oral everywhere, in practical orals, in interview also. Yes, I have given the choice. Just say, or let I will give the analogous example. Let I have a mobile phone whose camera specification are as follows. Let's see, 4 megapixel, 8 megapixel, and 12 megapixel. Now, which type of camera you will select? What is your answer?
Obviously for 12.
Yes, you will go for the 12. Why you will go for 12 megapixel?
If we consider for a processor,
Yes,
then the higher gigahertz will do the most of operations. That
yes,
means
yes,
most of
yes.
the process will done by the uh, speed of that machine,
Yes.
or that
Clock
frequency of that processor.
processor. Yes, yes. So the answer is very simple. Higher the clock frequency, better is the performance. That is the speed of the system is increases if you go for a higher clock frequency. That is what the simple answer. Like your mobile, if you go for a higher megapixels, okay, then the quality of your image is very good. That's why you are going for the higher megapixel. Just see. So likewise, if you go for a higher clock frequency, then it is possible to improve the or to get a good quality or good performance from your system. Okay, so that is what the answer. So this is what the performance measure of the system. So that is a crude way to measure the performance of system is by using the clock frequency. Okay, or another measure is called as instructions per second. That is the same thing. That is how many instructions are executed per seconds. So that is what we have seen in RISC and CISC architecture. That is mega instructions are executed per seconds. That is what the advantage of this RISC and CISC architecture. Okay, but this is called as not a good measures of performance. Okay, you cannot use these measures to uh, measure the performance of your system. Okay, for example, digital camera example of digital camera is given. So a user cares about how fast it processes images. Okay, not clock speed or instructions per seconds. So if you take a simple example of digital camera as an embedded system, so while purchasing the digital camera, whether the customer will be worried about the clock frequency of the digital camera, okay, or the instructions per executed per seconds by the digital camera. So these specifications are not known by the customer. Okay, whatever the general customer, it doesn't know about the internal clock frequency and the number of instructions executed per seconds. Okay, so these design metrics are not a good design metrics as a measure of your performance. Okay, so what are the good design? What are the good design metrics to measure the performance of your system? So first performance design matrix is called as the latency time, or also called as a response time. I think you might have completed in this pro, but I think you have not completed because we have just completed first 3 minutes. Is it clear? Latency time. So first criteria is called as a latency. Okay, or it is also called as a response time. So the definition is very simple of latency time. The time between the start of the task and the end of the task is called as a latency time or the response time. Or I will give a simple example, analogous example, that is, let if I ask some question, right now I have asked some question, which technology we have to use, okay, the technology ABC. I have put the questions. Now you will take some time and after that you will give some response to me. Okay, so how much time is required? Still I ask some question and I will get the answer. Let's see. So that is called as a latency time or the response time. Okay, that means how much time is required for your embedded system to respond to the given given task. Okay, so this is what simply put in the words, that is latency time or response time is nothing but the time between the start and end of the task. Okay, now one example is given for camera. Let I have two camera A and camera B. Okay, and camera A and B processes images in 0.25 seconds. That is, only 0.25 seconds are required to capture the image. I have to capture one image from the camera. So if I click the button, okay, That is, I will start the process and the camera will capture the image, okay, and store it into the memory. So this particular time of pressing the button and capturing the image, so that time is 0.25 seconds. So this is called as the response time, okay, for this example of digital camera. Or for whatever the example we have taken, that is, I have asked some question to all the students. Okay, so the time at which I have asked the question and the time I get the answer. So whatever the time in between this, that time is called as the response time or the latency time. Okay, so quite simple. So this is the first design matrix. Now the second design matrix is called as throughput. Okay, so what is throughput? Anybody? I have explained it in the previous lectures also. What is throughput? What is throughput? Anybody can unmute yourself and give the answer, or put into chat box.
Amount of numbers that is passing through the system.
Amount of, hello, Onkar.
Sir. Amount of number that is passing through the system.
No, actually, that is
Amount
it is really it's
of
some
process that is passing through the system.
process. Just see, throughput. It's very simple actually. Throughput means number of tasks, okay, executed per seconds. That I have given you people 10 tasks, okay. So how many tasks you will complete within a unit time? Okay, for example, I have given 10 assignment to you people, and I have assigned a deadline of 1 day, okay, 24 hours. So how many assignments you will complete within a 1 day? That is called as a throughput. Okay, so the general definition for throughput is number of tasks executed per seconds. Okay, so that is called as a throughput. Just it's very simple. I have assigned some task to anybody, okay, and I have to measure the performance of that person. So I will give some task to that people or that person, and I will ask him to complete within a time. I will give the deadline, maybe like 1 second, 1 minute, 10 minutes, likewise. And number of tasks will be completed within that unit time. Now that is called as a throughput. Getting? So now in this case, we have taken the example of digital camera. Okay, so latency time, sorry, throughput is nothing but here. That is, let I have camera A and B, and let camera A processes 4 images per second. Okay, that means within 1 second, my camera A will processes or capture the 4 images. Now, so what is the throughput of camera A? It's a 4. Are you getting? So camera A will capture 4 images per seconds. Okay. So the throughput of camera A is 4 images. Or maybe I have second camera, camera B, that can capture the 8 images per second. So the throughput of my second camera, camera B, is 8. Okay. So this is all about throughput. Are you getting, everybody? Throughput, the number of tasks executed per seconds. For example, camera A will execute or capture the 4 images per second. So the throughput of camera A is 4. Okay. Now the third parameter is called as a speed up design matrix. Okay. So here you have to compare the speed of let camera A and B. Let I have camera A and camera B. Let camera A will capture 4 images per second, and let camera B will capture the 8 images per second. So I have to find out the speed up parameter. So the speed up of camera B over A is found out by using simple formula, that is S equal to B's performance, S equal to B's performance divided by A's performance. Okay. So what is B's performance? That is camera B can capture 8 images. So 8 divided by A's performance. What is A's performance? That is camera A can capture only 4 images. So 8 by 4 equal to 2. So that is called as a throughput speed up. Okay. So this is how I can compare the speed of my all the different system. Let camera is my one system, camera B is my another system. So I can compare the speed of these two systems by using this third parameter called as a speed up. So speed up is nothing but the B's performance divided by A's performance. So 8 by 4 is equal to 2. So just remember, these are the three important performance design metrics of your embedded system. First is a response time, that is number of tasks executed. That is a time between the start of the task and the end of the task. Throughput, number of tasks executed per seconds, and speed up is we can compare the performance of both the systems, or two systems we can compare the performance. So that is all about the performance design metrics. So I think that this is clear. Just say right now I have only 1 minute for the Zoom meeting. It may disconnect at any time. So try to rejoin the same link. We'll see whether it is possible to rejoin the same link or not. And also I will put the attendance on your WhatsApp group. So I don't know, maybe within a minute it will stop. We will again rejoin on the same link. Is it clear, everybody? The performance design matrix. If you have any problem, let me know. If you are not getting the definition of any of these design metrics, response time, throughput, and speed up.